In addition to being able to compose two functions together, there are times when we may need to be able to determine the components of a composition function, or kind of decompose it if you want to think of it that way. And it turns out that it looks like a very difficult process, but there's actually a very simple way that we can approach this. Now, it's important to recognize that there are multiple correct answers for decomposing a function. However, we're going to look for the most obvious, the easiest to work with. So what I want you to basically do is to look at the overall function and ask yourself, what is the expression that is isolated? So in other words, how is it grouped differently? So maybe it's inside parentheses, maybe it's under a radical, maybe it's under a division bar, but we're looking for the expression that is isolated, and that's going to be our input function. We're going to pull that expression out and replace it with an x, and then that's going to be our other function. So let's look at an example, because I think it's a little bit easier to understand what I'm saying if we just look at an example. Find functions f and g such that f composed with g is equal to h if h of x is equal to x squared plus 1 to the quantity 50th power. So we're looking for functions f and g such that f composed with g is going to equal x squared plus 1 quantity to the 50th power. So in this case, what is our input function? F of x or g of x? Well, let's go back to f composed with g. The one listed second is always the input, so this is our input function. So we're going to define g to be the isolated expression. So if we look at h of x, which of those expressions are isolated? Well, clearly inside the parentheses, we have x squared plus 1 that has been isolated from everything else. So that's going to be our input function. And then f of x is going to be, well, simply think about if we were to come in here and get rid of all of this that we just pulled out and called g and replace it with an x, what would be left? Well, x to the 50th power, and that's going to be our f of x. So functions f and g such that f composed with g would equal h would be f of x is x to the 50th, and g of x would be x squared plus 1. And it's important to recognize they have to be in that order. If you were to flip them and let g of x be x to the 50th, you would be wrong, because then you would be putting x to the 50th into f of x, and that's not what we want. All right, let's look at another example here. We have find functions f and g such that f composed with g equals h if h of x equals 1 over x plus 1. So again, we're finding f of x and g of x. Which of these is going to be our input? Based on the way that it was written, g is written second, so g is going to be our input function. So what is the isolated expression in this case? X plus 1 is on the bottom of a division bar, so it is isolated from everything else. So x plus 1 is going to be our g of x. And if we get rid of x plus 1 and replace it with just x, f is going to be 1 over x. So the key with finding the components of a composite function is to look for that isolated expression. Let that be your input, and then remove it and put an x in its place, and whatever's left is going to be your other function.